Oh, I'm sorry. I forgot. I do have this one. This is big ideas.
It's right.
It's all right. For some reason, I had it confused with another student. Okay, what page?
396.
Which numbers?
So it's from 19 to 25.
Okay. Solve it by using least common denominator. Check your solutions. What am I going to do? What's the least common denominator on 19? Well, now hold on a second. There's a couple of ways to do 19. When
Okay.
you say solve it by using least common denominator, there's still two ways to do that. You can add the two fractions using the least common denominator, or you can multiply both sides of the equation by what is basically a least common denominator, getting rid of all denominators at once, which is actually my preferred method. And I don't know, but I suspect that's what they're talking about also. Let me go up to their example and see if I can figure it out. As to what they are doing. No, it really doesn't look like. I don't see what they're doing, but that doesn't matter. Let me show you what I mean.
Okay.
Because I still think that this is the best way to do it. If you can get rid of all denominators in one step, do so. Well, what do I got to multiply the left side by to get rid of all denominators?
So you can multiply 2x, or
If I multiply the left side by 2x, I got to multiply the right side by 2x.
right.
What's the left side become?
4x.
Well, distribute that 2x to both of these terms. The right side becomes 4x, but I said, what's the left side become? I want to work from left to right always.
Right. Yeah. So
What's 2x times 3 halves? That's step one.
uh, 6x over 4x. So
No, it's not 6x over 4x. It's 6x over 2. When you multiply,
right. You only multiply the top.
well, first of all, you should cancel the 2's. That's the easy way to do it, like that.
Okay.
So what do I have?
So 3x plus 2
Equals
2. Oh wait. 4x.
finish solving it. Now, first of all, notice one thing. Notice how much easier this problem is than what we started with. So by getting rid of denominators as my first task, I have simplified the problem considerably. Now solve it.
So subtract 3x from both sides. So it's 2 equals x. So that's it.
Okay. Now, the alternative to that method, and I'm not sure which one they're really suggesting because they say use least common denominator. Well, I would find the least common denominator there, which is 2x. But to me, this is a bit harder. Let's see. Least, in fact, it got me screwed up here. I need a 3x right there. And then this one, I need a 2. So if I do it this way, now I've got 3x plus 2 over 2x equals 2. Now I multiply both sides and I end up with this, but look at how many steps it took me to get to that.
I know.
Much faster to do it the way I first suggested, which is to multiply both sides of the equation by your least common denominator. And it's going to be more valuable in number 20. You'll see why here in a second. Rather than solving 20 by finding a least common denominator for those two terms, find a least common denominator for all three denominators.
Uh, 18x?
Least common denominator.
Okay.
18x is a common denominator. I'll give you that. But it's not the least one.
So it would just be 3x?
Be 6x. Remember what has to be true. Every term, if this is, I'm going to go with your least common denominator. You said 3x. Okay? Well, that has to be evenly divisible by all three denominators. Passes that check, but it's not evenly divisible by 6. Fails that check.
Okay.
So the definition for least common denominator is the least number that is evenly divisible by all three of these things. And what is that? 6x. 6x is divisible by 3x, 6x is divisible by 6, and 6x is divisible by 3x. Okay? So that's what we're going to multiply both sides of the equation by, is 6x. And that's going to get rid of all the denominators in one step, leaving us with the smallest possible result. So what's the left side become?
4 plus x equals 8.
Much easier. Especially with this particular problem, it's easier. In other words, it wasn't that much easier on 19, but on 20, it's a ton easier to do it all in one step rather than in partial steps.
Right.
21. I assume we have to do everyone?
Up to 25.
Okay, 20, so 19 through 25?
Yep.
Okay, hold on 1 second. Come on. dog's having a seizure again. So in 21, what's my least common denominator?
So it's
Well, what's one way to always get a common denominator?
multiply both denominators.
So here's my a common denominator is this, right? So if I'm going to get rid of both denominators in one step, that's what I'm going to do. I'm going to multiply the left side. When I say the left side, I mean all of it, like that,
Okay.
by that. Can you tell me what that is?
So like so the x squared minus 4x.
Okay. First of all, is this your first step?
Oh, yes.
What does it leave?
Right. Now it's just x squared minus 3x plus 4x.
Well,
Or is it just plus 4?
well, I have to multiply that forward by that whole thing.
Okay.
In other words, the x minus 4, actually that first step I made was not correct. Hold on just a second. I got problems here. Sonny, come here. Sir, girl, can you get in here? Let me think about this for a second. Let's see. All right. I do want to multiply both sides by that quantity. But I got to be a little careful on the left. In other words, I'm multiplying the whole left side by that. Well, the first term ends up being x squared minus 3x. But then I got to multiply all of that by 4. So, is that a negative 4? It is. No, it's a plus 4. So, plus 4 times x minus 4 times x. So that's my left side. What's my right side? I got to multiply the right side by those same two.
So it's 3x squared minus 12x.
Yeah. Now, I guess at this point I've got to distribute this. So that's x squared minus 4x. And then I've got what? X squared minus 3x plus 4x squared minus 16x equals 3x squared minus 12x. Which side do I want to put everything on?
So the right side.
Actually, here, before I ask that question, that was not fair. Let me combine the terms on the left side. I was looking at it incorrectly myself. Now, which side do I want to put everything on?
So
I'm looking at a quadratic.
yeah.
When you put it together
So
a
left side.
quadratic, you want the coefficient of the x squared term to be positive, always. So which side do I want to put everything on?
The left side.
solve that?
So
Go through your priorities on factoring. You know it's a factoring problem. Quadratics are always factoring problems.
so
Is there a greatest common factor you can take out? That's step one.
you can take out an x.
Okay. Leaves what?
2x minus 7.
Now solve that.
So
What's the first thing that x could be?
seven halves.
That's the second thing. First
Oh,
thing would be 0, right? In other words, either that's 0 or that's 0.
oh yeah.
Okay. However, there's a problem with both of these answers. Let's go back and look at our problem. Is 0 a possible answer?
No.
No, because you cannot divide by 0. Ever.
Right.
In other words, this is inviolable. And by that I mean you can't violate it ever. You can never divide by 0. So x can never be 0, x can never be 4. So the 0 solution gets thrown out. And the only
Right.
solution at all that works is 7 halves. That one was definitely a little tougher. You don't see too many polynomials that end up with extraneous solutions,
Yeah.
but that's one of them. Usually I tell people that if you're looking for extraneous solutions, it's going to have a radical sign, an absolute value sign, or a log in it. And in fact, I think I've made the statement that you almost never see a polynomial that has an extraneous solution, but here's an exception to that rule.
Okay.
Might actually be a little bit easier way of doing that. Let's just examine it. Notice how long it took us to do it the way I did it.
Yeah.
Well, first of all, let's start off by crossing out those x's. And now I got x minus 3 over x minus 4 plus 4 equals 3. Move the 4 to the other side, and I got minus 1. Basically cross multiply, and I got this. Move the x's over, I got 2x equals 7, x equals 7 halves. It never even gave me the other solution that was extraneous in the first place. Look at how much quicker this was. Merely, and the only thing I did was cross out those x's. Well, I can do that. You can always do that. There's no rule that says I can't do that as my initial step. Just cross it out. Other than the instructions they gave you on this, which was to solve it using lowest common denominator.
All right.
But still interesting to know that we simplify the problem tremendously by just crossing off those x. All right, number 22. What am I multiplying everything by?
X minus 3 times x.
Okay, tell me what that makes the left side.
2x plus X minus 3.
Now you got to multiply the right side by that. What's the right side become?
X squared minus X.
Now, my coefficient's already positive over there, so I'm moving everything to the right side. The left side at this point is 3x minus 3. So I'm going to move all of those over, and I've got x squared minus 4x plus 3. How do I solve that?
So
Simple factoring problem.
right, yeah.
Go through the steps of factoring. It's first step.
The X,
Second,
and then the sign is both negative. And
need factors of 3 that add to 4.
3 and 1.
And the solution?
So X is 3 and X is 1.
Now let's go back and check and make sure we don't violate any domains. We're looking at 22. Can x be 3?
No.
Cross that one out. The only solution we
So
have is x equal 1. So I'm beginning to see that when you have a lot of these rational quotients, you can have extraneous solutions. 23, what are we going to multiply the left and the right by?
X plus 4 and X minus 1.
Not at and, but times x minus.
Oh, yeah, times X plus 1.
Okay, do that. What do I get on the left?
So 6x squared minus 6x plus.
And I would suggest doing this. Always do this. Don't try to do
Yeah.
that in your head. You're just asking for mistakes. So that's my left side. How about my right side?
So it's.
Write it out. You don't have to, once again, you don't have to do it in your head.
So.
Right?
Yeah.
Okay. Now we simplify. Okay. So we're going to have to multiply these two terms together. Let's do that. What's that give you?
X squared minus 5x.
Well, it's minus 1x plus 4x, which is plus 3x.
Oh, plus 3x. And then minus 4.
Okay, now I got to multiply all of that by 4.
So 4x squared plus.
Let's just write it out from the start.
Okay.
Most important thing is here is don't make a silly error. Okay, that's my left side. What's my right side? Whoops.
Plus 2x.
And then plus another 8x, so it's plus 10x.
and then plus, I think that's 8.
Right. Now, which side am I going to gather everything on?
The left.
Yeah, and I've got a total of 10x squareds over there minus a 2x squared. So I'm going to end up with 8x squared. Takes care of that term, and that term. What have I
And
got
then
in terms of x's? I got plus 6x minus 10x minus 4x. Takes care of that term, and that term. And then I have minus 24. Now what?
you can take out a 4 from all of those.
Okay, so I get 2x squared minus x minus 6 equals 0. Now, once you get above the first level, it's hard for me to tell whether that's going to be factorable or not. About the only way for me to tell is to try it.
Right.
First,
So on both sides.
what on both sides?
X.
No, if I had an x there and an x there, they wouldn't multiply to 2x squared. I got to have them multiply to 2x squared. In other words, the first step is to split up the 2x squared.
Okay.
So one
So
of them got to be 2x.
yeah.
Hold on. All right. Sorry. Okay. Now, what are the signs?
One's positive, one's negative.
And because those coefficients are different, I got to allow for both cases.
Right.
Now, factors of 6. There's 6 and 1, and there's 3 and 2. I don't know. I'm going to try 3 and 2 because I always try the two closest ones.
Yeah.
And I can kind of tell that if I put the 3 here, that's not going to work. In other words, if I put the 3 there, there's no way I'm getting there. So let's just start by putting the 3 over there and the 2 here.
Okay.
And you'll notice that that does produce the right coefficient. It just may be the wrong sign. It produces a plus x instead of a minus x. So what does that tell me I got to do?
Switch the numbers.
Well, the 2 needs to go with the minus sign there.
Right.
And the 3 needs to go with the plus sign. And there is my answers. Well, those are my factors. We're not done. So what are my answers? And then we're going to have to check them, make sure we don't violate any domains.
So x equals 2, and then x equals 3 halves.
Negative 3 halves.
Negative 3 halves.
Okay, and this one is 23.
So
None of those appear to violate any of the domains. Now, I'm not certain that that necessarily means they both work. If my life depended on it, then I'm trying both of these numbers. Okay, 2 is really easy. What does that become? 12 over 6 plus 4, is that equal to 6 over 1? Yes. So 2.
yeah.
I think the only time you're going to find a solution that doesn't work is if it violates a domain. In other words, I don't have much doubt that this one's going to work also. In other words, the main thing I'm looking for is to not violate domains.
Okay.
It's not really worth going through the math to show you that that works just because it takes so much time. I'd rather go on and do the rest of these. Each one of these has a lot of math in it, as you can tell. A lot of algebra is what it is.
Give me 1 sec. I need to grab my charger for my computer.
Sure. Still there?
Yep.
Okay.
Yeah,
Notice
it just it was lost, but
okay.
it's fine.
Okay. Notice on 24. We could do it the same way we've done 22 and 23. Okay.
Okay.
But let's just look at it for a moment. I can get rid of this denominator pretty easily by just multiplying both sides by x minus 4, right?
Yeah.
But it won't get rid of that denominator. So then I'm going to have to multiply both sides by x as a second step. That's the reason we do it all in one step instead of two. In other words, I'm going to multiply both of them in one step by x minus 4 and also by x. So
Okay.
the left side becomes
10x minus 40 plus 3 times that.
3 times what?
X minus 4 times x.
Just the x minus? No, you're absolutely right. Sorry. What's the right side become?
X squared plus 9x.
What's the next step?
So,
Get rid of the parentheses.
yeah.
That's kind of like my two go-to things. Is you get rid of parentheses, you get rid of denominators. Well, we just got rid of all the denominators. Now we got to get rid of the parentheses. So
Okay.
what do we got here?
So, plus 3, or hold on. So,
Probably the best way to do that is to do those two first.
so that's x squared minus 4x.
And now multiply each of those by 3.
3x squared minus 12x.
Yeah. I think that's the best way to do it. And now let's simplify the left side before we decide which side we're going to put everything on.
Okay, so minus 2x and then minus 40.
Okay. So now we got this. Now we know which side we're going to put everything on. What's the next line?
2x squared minus 11x minus 40.
Equals 0. Very necessary part of that.
Okay, yeah.
These are all equations. You got to keep it an equation. You can't change it to an expression. Okay. Now, again, they're making it a little more difficult because they're giving us a lot more factors for this constant, but I'm going to give it a shot.
So then, yeah. So 40 and 2, 10 and 4.
40 and 1, 20 and 2, 10 and 4, 5 and 8. And that should be it. Which are the two closest together?
5 and 8.
That's what I'm starting with. 5 there, 8 there. Gives you minus 16 plus 5. Bingo. Got it on the first try.
Nice.
Well, it's amazing how often you will get it on the first try if you just follow the suggestions that try the two closest together. Only because Colorado makes it easier for you by usually giving you problems where the solution is the two factors that are closest together. And
Okay.
yeah, that produces a minus 11x. So what are my solutions?
So x minus 5 halves, and then x plus 8. Or equals 8, sorry.
Okay, and which one we were doing? 24?
Yes.
Neither of those appear to violate any domains. And the only domains that we could violate would be in the denominator. There's nothing wrong with x being minus 9. You can have that be equal to 0. You just can't have that be equal to 0, and you can't have that be equal to 0. All right, so we got one more here, 25, right?
Yep.
What am I multiplying everything by on 25?
So x minus 3 times x, right?
Exactly.
Or x squared minus 3x.
That's what that is. But we're going to multiply it like that. What's that make
Okay.
the left side equal?
So would it cross out both of them?
Cross
18?
out that full denominator, yeah. So 18 is
Okay, so it's just 18.
but it doesn't cross out all of that.
Right, so it's just 6x.
Correct. And the right side.
And then, so that's 5x minus 15.
All right. And solve that.
So 18 equals 11x minus 15, and then 18 plus 15 is 23, 33. Okay.
Now, does that violate any domains?
Yes.
Yeah. In fact, it violates a lot of them, doesn't it?
Yeah.
It certainly violates that one. So there's no way that can be an answer. So what that tells us, and it violates this one also, tells us that there is no solution to this, to 25. The only solution we came up with was 3, and that violates the entire left side of the equation.
Right.
Now, question is, did I make a math error? I'm not sure.
No.
I don't think I did. I think that there are some equations that are not going to have a solution.
Right.
And 3 is not a solution. You cannot divide by 0.
Right.
So,
Because my teacher said that there would be one or two that
okay, I have no solution.
solution.
Okay, good.
That's fine.
If my life depended on it, I would go back and I would redo my math.
Okay.
Because it's rare that I find a problem like this that has no solution at all. But this appears to be one.
Okay.
All right.
All right. Then,
You good to go for tonight, Dimitri?
yep, that's it.
Okay. Talk to you later.
All right. Yep.
Bye bye.
Bye.